So welcome to this second video about basic DC measurements, and now I'm actually in PROTEUS, and you can see that I've drawn figures 1 and figures 2 on this first root sheet or design sheet. And what I've done is I've placed 1, 2, 3 voltmeters, 4 voltmeters around resistors R1, R2, R3 and R4, and I've connected those 4 resistors to this 9 volt power supply called VS1. I've redrawn figure 1 as figure 2 over here, or as figure 1 again over here, and this time I'm going to measure the current through the 4 resistors. So I've got a milliammeter here, a second one here, a third one here, a fourth one here, and a fifth one here. So in figure 1, what I want to do is I want to measure the voltages across the resistors and the currents flowing through the resistors. To do that, when I've drawn the circuit diagram up, all I've got to do is go down here to the lower left-hand corner of the screen and press this play icon. And when I press play, PROTEUS starts to simulate, and you can see now that I've got those readings. I'll just zoom in briefly to get the readings. So the voltage across the first resistor is 0.5 volts, across the second resistor 1.1 volts, across the third resistor 2.36 volts, and across the fourth resistor it's 5.03 volts. And if you add those 4 voltages up, they add up to 9 volts. Let's look over and see what the currents are flowing through. I've got 5 milliamps flowing through the first resistor, 5 milliamps flowing through the second resistor, 5 milliamps through the third resistor, and 5 milliamps through the fourth resistor. So the same current is flowing through all of the resistors in this series circuit. You'll notice that these resistors are labelled R5, R6, R7 and R8. They're actually really the same resistors R1, R2, R3 and R4 that I have over here. It's a quirk of PROTEUS that it just relabels every resistor starting as R1, R2, R3, R4. Your next ones will be R5, R6, R7, R8, then R9, R10 and so on and so forth. Okay, so it just increases the labels by 1 each time. Okay, so don't worry about that if that's coming up in PROTEUS. So figure 1 was to measure the voltages and the currents, and we've done that. Okay, let's look down here. On figure 2, I've got 3 resistors in parallel. I have 5 volts connected across R9, R10 and R11, and I should measure 5 volts across each of those resistors, which I do using this DC voltmeter. However, there will be different currents flowing in each of those resistors. I've got 50 milliamps flowing down through R12, 22.7 milliamps flowing down through R13, and 10.6 milliamps flowing down through R14. So that was the first root sheet or design sheet that I want you to draw up. I'm going to press stop now, and that's that simulation finished. So you should be able to draw up those 4 circuits as I've done here in PROTEUS on your design sheet, and then you save it, you press play and your simulation should work. Now if I go up to design here and look at root sheet 2, you can see that I've got the second set of figures. I've got figures 3, figures 4 and figures 5 here. And again, you draw these circuits up, you place your voltmeters and your ammeters, and you press play. And then you should get the readings, as I've shown here. For figure 3, you've got 2.62 volts across R15, 2.38 volts across R16, and 2.38 volts across R17. In terms of currents, you've got 262 microamps through R18, 23 microamps through R19, and 23 microamps through R20. So in terms of this voltage dividers one, we've got 8.28 volts across that resistor R22, and this one here is slightly unusual. I'm pumping 200 milliamps into the circuit using a current source. 137 milliamps flows down through R23 and the rest of it flows down through R24. So that's that particular circuit simulated. And again, that was your second root sheet. And if you go down to your third root sheet here, you've got the last circuit. And again, if we press play here, you will see readings for the current, 100 milliamps, and for the voltages across each resistor coming up. So you've got 1.2 volts, 2.2 volts, 5.6 volts, and 1 volt. And if you add all those voltages up, they should add up to 10 volts. So that is our circuit simulated in PROTEUS. Okay? And I want you to do those circuits in PROTEUS yourself. Draw up this particular thing. I've saved it as DC analysis, and you should be able to get that working in the student edition of PROTEUS. Okay, thanks for listening, guys. Well done.